So we have finally reached the end of our project, and in this project we have discussed a lot about microstrip patch antenna and how it is easy to manufacture, fabricate over simple antennas. We have talked about different types of microstrip patch antennas. We have categorically discussed on rectangular microstrip patch antennas and circular microstrip patch antennas. We have also discussed extensively on defective ground structures and how it can be implemented to improve various properties of antenna, and we have seen the software implementation of the different structures. Talking about the rectangular microstrip patch antenna we have designed in this project, it finds applications in three different bands, that is 2.36 GHz UMTS band, WLAN in 5.28 GHz, and X band in 8.64 GHz. This microstrip patch antenna finds extensive use in militaries for radio location over land, airborne, and naval radars. Because of its applications in WLAN and UMTS, this antenna can be used for several other applications like in biomedical to track health of the military personnel who is on the mission. Also help in security services and in wireless communication. With the help of this antenna, we can track the location of our army personnel and also communicate with them at distances which is otherwise difficult to communicate. Next, Agni will talk about the circular patch antenna applications and the future scope of this project.
Hello again everyone. Now in order to conclude the cmsa aspect of our project, we can see that the proposed circular microstrip patch antenna with DGS has resonant frequencies at 3.95 GHz, 4.34 GHz and 6.32 GHz. Some of the notable applications respectively thus include access to International Mobile Telecommunications Advanced Band, which are the requirements issued by the ITU radio communication sector of the International Telecommunication Union in 2008 for what is marketed as 4G mobile phone and internet access service. An IMT advanced system basically aims to provide a comprehensive and all-secure IP-based mobile broadband solution to laptop and computer wireless modems, smartphones, and other mobile devices. Facilities like ultra-broadband internet access, voice over IP, gaming services, and streamed multimedia is also provided to users. It accommodates the quality of service and rate requirements set by further developing existing applications like mobile broadband access, MMS, video chat, mobile TV, and also news services like HDTV. 4G also allows roaming with WLANs and interaction with digital video broadcasting systems. The next resonant frequency is at 4.34 GHz, so it can be used for W-band applications. A W-band or wireless body area network is basically a wireless network of wearable computing devices. These devices may be embedded inside the body, implants, may be surface mounted on the body in a fixed position, in wearable technology, or may be accompanied devices which humans can carry in different positions, like in cloth pockets by hand or in various bags. It can use W-band wireless technology as gateways to increase their range. In this way, it is possible to connect wearable devices on the human body to the internet. Initial applications of W-bands are expected to appear primarily in the healthcare domain, especially for continuous monitoring and logging vital parameters of patients suffering from chronic diseases such as diabetes, asthma, and heart attacks. For example, a W-band network can alert the hospital even before a patient suffers from a heart attack through measuring changes in vital signs. Or it can even auto-inject insulin through a pump as soon as the insulin level of a diabetic patient declines. Other applications also include sports, military, or security. It also resonates at 6.32 GHz. So the proposed antenna can operate from 4.8 to 6.6 GHz, making it suitable for wideband applications. It has applications in the C-band as well, which include the domains of WiMAX, long-distance radio telecommunication, radar, and satellite communication. Also, it is well equipped to handle maritime communications and maritime military systems. The future scopes of this project include hardware implementation of the proposed wearable antenna. We can physically fabricate this antenna and test it out and analyze its parameters. 2. Analysis of multiband characteristics of the MSA using other wearable substrate. Here the substrate has a dielectric constant of 1.6. We can also use other dielectrics corresponding to other wearable materials like jeans, buttons, etc. and simulate the model and analyze the results finally. Number 3. The equivalent circuit representation of the proposed antenna can be analyzed. And finally, number 4. Realization of other wireless application bands with different resonators. We can even test it out so we can use it in other notable bands. So that's about it for our project. We hope you found this video interesting and informative. Thank you so much for your time.